In this series of lessons on landing gear, you will learn about the design and construction of both fixed and retractable landing gear, including retraction systems using hydraulic power. Steering will be discussed, and landing gear indicating systems will be explained, as well as the emergency lowering and safety systems that are available on most modern aircraft. In this first lesson, we will discuss the functions of the landing gear and then describe the various types of fixed gear. A detailed explanation will also be given of the operation of the oleo pneumatic strut. The functions of the landing gear are to provide a means of maneuvering the aircraft on the ground, to support the aircraft at a convenient height to give clearance for engines, propellers and flaps, and to facilitate loading and to absorb the kinetic energy of landing and provide a means of controlling deceleration through the brakes. Once airborne, the landing gear serves no useful purpose and is effectively dead weight. A vast amount of research has gone into the design of landing gear units in order to reduce their weight and the space they occupy when retracted. There are two types of landing gear layout. They are the tricycle layout, where there is a nose wheel unit forward of two main gear units, and the tail wheel or tail dragger type, with a tail wheel behind the main wheels. The tricycle gear has a number of advantages over the tail wheel type. There is no danger of tipping over onto its nose whilst taxiing in a strong tailwind. And there is a greatly improved forward view on the ground for the pilot. And lastly, it produces a much more level platform for loading. For these reasons, most aircraft now use the tricycle layout, with the two main gear units being positioned just aft of the center of gravity, supporting up to 90% of the aircraft's weight and absorbing all of the initial landing shocks. The nosewheel unit keeps the aircraft level, and in most cases also provides a means of steering. With slow, light aircraft and some larger aircraft for which simplicity is of a prime importance, a fixed, non-retractable landing gear is often fitted. However, the reduced performance caused by the drag of the landing gear during flight is offset by its simplicity, its reduced maintenance, and also its low initial cost. With higher performance aircraft, reducing the effects of drag is more important, and the landing gear is retracted into the wings or fuselage during flight. There are, however, penalties of increased weight, greater complication, and additional maintenance. There are three types of fixed landing gear shock absorption systems in common use. Those which have a spring steel leg, those which employ rubber cord, and those that have an oleo pneumatic strut to absorb shocks. Spring steel legs are usually employed at the main landing gear positions. The leg consists of a tube or strip of tapered spring steel, the upper end being attached by bolts to the fuselage, and the lower end terminating in an axle, on which the wheel and brake are assembled. When rubber cord is used as a shock absorber, the landing gear is usually in the form of tubular struts, designed and installed so that the landing force is directed against a number of turns of rubber in the form of a loop. Some fixed main landing gears, and most fixed nose landing gears, as well as almost all retractable landing gears, are fitted with an oleo pneumatic shock absorber strut. The design of individual struts varies considerably, However, the operating principle is the same for all.
A simple oleopneumatic strut consists of two concentric cylinders, one free to slide inside the other.
The cylinders are filled with hydraulic fluid and gas. The fluid and gas are kept apart by a separator piston. In this example, the outer cylinder is fixed rigidly to the airframe structure. It houses the lower inner cylinder and piston assembly. The wheels and axle are connected to the bottom of the inner cylinder. The inner cylinder is free to rotate and move up and down within the outer cylinder. However, rotary movement is prevented and up and down movement is limited by the torque links, which connect the inner and outer cylinders together. These links are sometimes also known as torsion or scissor links. The main gear is subject to torsion loads during ground maneuvering, and these loads are taken by the torque links. The smaller the radius of the turn, the greater will be the load felt by the torque links. So all turns should be made as wide as operationally possible. The area above the separator piston is filled with hydraulic fluid, and the area below is inflated with compressed gas, which may either be of air or nitrogen. The separator piston is a free-floating piston, which keeps the fluid and gas apart. The gas supports the weight of the aircraft on the ground, cushions bumps during taxiing, and absorbs the shock on landing. The purpose of the fluid is only to dampen oscillations and control the rate of compression and extension of the cylinders. The piston connected to the lower cylinder has holes in it, which restricts the flow of fluid through the piston, thus dampening the movement between the cylinders. There is a component known as a flutter valve, which is fitted to the lower cylinder piston assembly. The flutter valve consists of a free-floating circular plate with a large central hole. It is free to move up and down within its housing. In the top of the inner cylinder, there is a small central orifice, plus a series of holes around the perimeter. If fluid is flowing upwards, the plate will be pushed up with it, blocking off the outer holes and allowing a limited flow only through the central orifice. However, if fluid is flowing downwards, then the plate will be pushed down, allowing a greater flow of fluid through all of the holes. The flutter valve will therefore limit the rate of movement more when the strut is extending than when it is contracting.
With the aircraft stationary on the ground, the gas pressure will support the weight of the aircraft, with the lower cylinder approximately midway up its stroke.
Bumps during taxiing are cushioned by the gas pressure and dampened by the limited flow of fluid through the orifice. After takeoff, the gas pressure will cause the lower part of the leg to extend to its fullest extent. On landing, however, the strut shortens and fluid is forced through the flutter valve. This restriction limits the speed at which the strut compresses. As the internal volume of the cylinders decreases, the gas pressure rises until it balances the downward force of the landing aeroplane. As the downward force of the landing decreases, the gas pressure acts as a spring and extends the strut. The flutter valve plate will move up with the fluid flow, blocking off the outer holes and further reducing the speed of upward movement of the outer cylinder, thus helping to prevent a bounce on landing. Evidence of a strut gas leak will be given by the strut not extending as far as it should with the aeroplane standing on the ground. In the case of the main gear, uneven amounts of shiny metal, which forms the hard outer coating of the strut, will be shown on each gear leg, with less shiny metal being visible on the leg with a gas leak. There are a number of methods used for connecting the wheel or wheels to the undercarriage leg. The most common methods are fork, half fork, cantilever, dual wheel, and multi-wheel using a bogie or truck. The methods are fairly self-explanatory, and an example of each is shown here. That's the end of the lesson. You should now know the 3 different types of fixed landing gear in common use today. Remember that it is the gas in the oleo-pneumatic strut that supports the aircraft and absorbs the shocks. The purpose of the fluid is to dampen oscillations and control the rate of movement of the cylinders. The torque links prevent rotary movement between the 2 cylinders. Finally, remember the methods commonly used for connecting wheels to the landing gear legs. You can test yourself on this by dragging the names from the list onto the correct pictures using your mouse.